for 100 degrees centigrade, and the loss was say 20 joules of energy. So in one cycle you got 80 joules of energy. Okay, but if you could supply instead of 100 kilojoules, 80. Okay, but if instead of 100, if you could supply 500 kilojoules of energy, loss still remains 20 joules. So you got 480 kilojoules per cycle. So input was 500, you got 480. Your input was 100, you got 80. So because 20 is loss. 500 kilojoules, 480. 100 kilojoules, 80. So in this way the efficiency increases because you are able to supply more energy per cycle, which is the same amount of loss.
Which 20 kg loss will be there? And
Kilojoule, not kg.
Kilojoules.
Joule is a unit of energy. So efficiency is energy supplied divided by energy you found. You got. Energy you received divided by energy supplied. That is efficiency. आपने 10 जूल एनर्जी लगाई और आपको 5 जूल एनर्जी मिली. That means you have 50% efficiency. JOULE. So energy's unit is joule or calorie or many other units. So the point is that the amount of energy always in anything, the energy which you apply, the output you will get little less only because of losses. Energy will be lost at some places. Temperature loss is there, frictional losses are there. Okay? So the efficiency means if you apply 100 units of energy and you get 80 units as output, then you have 80% efficiency. If you supply 100 units of energy and you get 50 units of output, it is 50% efficiency. So this way the efficiency of the plant increases if you have superheated steam and cool water.
That cycle steam is converted into water, that condenser.
Here steam is converted into water, here water is converted into steam.
Project.
And then the
50 degrees Celsius, some iron will be found. Then
That's why there is a limit, 550 degrees centigrade. If you go beyond that, beyond 600 degrees centigrade, then the machines will start deforming because the material of the machine is not so strong. So the material of the machines that define your how much superheated you can go. Otherwise we can go 1000 degrees also, but machines are not able to take it. Tubes are there and all these things become deformed.
Tubes will bend.
All these steam, by what it will be taken?
Tubes.
Yeah, tubes will be there.
What is the metal?
Metal used is steel and mixed something.
and what is the
No. The tubes, materials which are to be used should be, depending on where it should be either good insulator or good conductor of heat. Boiler is also not like this. Actually we have just drawn it like this. In actual sense, all these are tubes. Say this is the boiler. So water is passed and then there will be tubes. Water is passed from here and this converts into steam. And there will be fire here. You understand?
From up?
no
From anywhere. From anywhere. Say this is the place of fire. Here coal is sprayed and the fire is burned. Okay? So from a water container, the water will be pumped inside. Okay? And it will be passing through tubes like this. Okay?
In fire only there will be tubes.
Yeah.
Oh.
So now the heat will be transferred to water and water will convert into steam.
it is going with
This
heat.
is water, that container. There will be more fire only.
This is whole container. Water is supplied from here, it is in the tubes. And heat is passing to the tubes and the water is becoming heated.
Means in the whole container there will be fire. whole container, there will be fire.
The tubes
And
won't
you-
be burnt. The tubes won't be burnt.
Tubes are made like that. You can sustain.
Means
Makes it
after
difficult.
some days or after means.
No, they are designed in that way.
And they are checking after.
Yeah, they will check. Of course, checking will be done maybe yearly once, twice, or thrice. Because you don't otherwise shut down the plant. So okay, so this is the way heat is transferred because पतीली में जैसे हम in a container we just put fire from down is not a proper way of transferring the heat. This gives the maximum surface to be transferred. Less water is there all around there is fire. So easily the heat will be transferred. More efficiently the heat will be transferred. These are called heat transfer equipments.
So around the tubes, fire will be there. It's everywhere.
Everywhere. If there will be leakage,
They will be checking.
if like this happen,
Then they will do it.
Because
then
accidents
if we
happen.
lost, this fire will not burn like this.
It is not like that.
The water will be steam.
Anyway, it won't get steam so easily because either there is the amount of temperature is almost similar.
So there
Anyway,
are
it's not such an easy construction.
so there are
We going on the
accidents.
board, but try to understand the principle that water is converted into
Nuclear
steam.
power
The method used is that of
gas come.
the high flowing water through tubes.
If we come in the between
So now coming to turbine,
Turbine picture.
boiler you understood that water is converted into steam, superheated steam, 550 degrees centigrade. So now turbines are of different types. I will first explain the principle of turbine, which is very simple. No,
means
it's not any. Right now what we are doing, it's a very simple experiment.
It will not throw.
Just blade.
See,
But
if you throw water here, what will happen?
it
Jet
will
of
go.
water, jet matlab pitch kind.
It
What
will
will happen?
move.
This is shaft. If you throw water here, the wheel will move like this. This is travel.
and there are
If
so
you throw
many.
something with force here, it should drop. That is, if you have a jet incident here, it should drop. If you have more than one jets, at every place you have a jet. So it will give more energy.
So they are doing like this.
Correct?
So in thermal power plant they do this.
So this is called turbine. There is nothing else. It will give energy.
But
This rotates, okay? So this shaft in rotation. So here you say either you put steam or water jet or gas jet. So that will move.
the water jet is more easy than steam. Water.
But you need lot of water.
And
we can
also
do recycle.
force of water is also
By what? Recycle by what?
We have their energy. We have.
Electric energy. How you will recycle? Water has gone down. Now what you will do?
It's like that.
You will pump up with electricity. So you will consume more electricity than what you get. That's why that's not the closed cycle project. Hydro power plant is not a closed cycle project. We have a water already there up in the dam and that is used and then water goes away and then it cannot be fed back.
We have so much water.
Yeah. So that is called hydro power plant. But this is a closed cycle project. In this we are using the coal energy.
But if we make the some, when the water,
Just check.
so when the water goes down after the pressure comes here, so when the water goes there, then we can make some path to that so that the water can come again.
Again where? It has to go up. Because then only you will get energy. Otherwise, how it will come back? So hydropower plant cannot be closed circuit.
But we have so much
You have used just the height of the water. So height has come down, that's it. Because the water was at height, so it had that energy that is used to move, to convert it into motion. That's it, now it is used, it is down. In this we are using the coal energy to convert into steam, back into water, back into steam, back into water, so it is spread back. So anyway, whatever is there, if you incident here, so it should rotate in one direction. Are you able to understand this principle? This is turbine, nothing else.
And what are the parts?
So turbines will have just a shaft is there, and there will be blades of turbine on which the water will come, steam will come.
and
For a steam turbine, steam will come and it will push those blades in one direction. So it will start rotating. So turbines are of different types. Usually now what they are using are called axial turbines. Turbine is shown by this shape, where water comes from one part and goes. This is how the turbine is symbolized, symbol of turbine. So, and it gives rotation. This is shaft which gives rotation. So now, depending on, there is a radial turbine and there is axial turbine. In radial turbine, the input is from the edges. So this is the circle of the turbine, the shaft. So entry is from the edges.
What?
Entry of the fluid which turns the turbine is from the edges.
Sorry.
Not in this direction. It is in this direction. The entry is in this direction.
Sorry. Heck.
The turbine which we saw, which was moving, entry was like this. This can be called non-axial or radial turbine. Okay? Yes.
उसको ब्लेड पे एंट्री होगा सर
इधर
ब्लेड पे होगा ना
So this is blade here. So the entry is like this. Water comes and goes from the center. So water direction. The main thing is the direction of the water in an axial turbine. Radial turbine is coming from inside here and going out from the middle.
Is in that turbine there will be no blades.
Hmm?
There will be no blades.
Blades will be there, but the direction of the water or the steam which comes is from entering from here and coming out from middle.
What is this? This is turbine.
Yeah, this is shown as a turbine. It's a symbol of turbine.
Symbol of turbine.
So water which comes enters from here, actually enters from here and goes out from here. This is radial turbine. For an axial turbine, the water enters from here and comes out from here.
The symbol is like कौन सी किसकी
Anyway, you don't need to know actually the types of turbine, but it's dependent on it's designed in a way that axial flow of water will also, the water flow remains the same in the same direction as the axial. So this is turbine.
पहली वाली ब्लेड वाली I can
ऐसे वाली जो थी जिसमें ऐसे लग रहा था और मूव कर रहे थे. That also you could not understand.
only blade I understood only blade.
This was like this. It moves, so this will rotate. This you did not understand.
No, I understood that.
So that's it. That is the principle of turbine.
You get blade turbine. Like I understood that one is using
So then I just explained you the principle of turbine, that the water comes or the steam comes and it pushes the blades and so the turbine rotates. Now there are different types of turbines which are classified by from where the water enters and from where it comes out. So in radial turbine the water enters from the periphery of the turbine circumference of the turbine and
Up
comes out
from
from the
up
center. Yeah.
to now.
Up, or you say there is nothing up or down. This is turbine, so water enters from here and comes out from here.
And in that blade turbine from where
Both have blades.
both have
Both have blades, but in this, water enters from this direction and comes out from here. While in axial turbine, the water enters from, if you see from side, here the water enters from here and comes out from here. Okay? In axial turbine, water enters from here and comes out from here. It's the same direction. So this is how both are classified, radial and axial. That was known before. Three-dimensional drawing of usually the axial turbines are used nowadays for generating power in power stations.
that blade.
Axial turbines, blade wala, dono blade wala. But axial turbines, the
From-
blades are arranged in
from-
a way that the flow will come from here and go straight.
Ghost that turbines are there.
They are using that turbine. In aeroplanes also axial turbines are used. So now you can let now you see video on this. Axial turbines means that the water will enter into the turbine in this direction and will go out also from that direction. That is axial turbine. The blades are made in a way that water enters from here, still it will rotate the blade and goes out.
In jet engine also, these
Means
turbines.
blades are
turbines-
made like this one.
Blades are made in a way.
In jet engine also there will be turbines, and that shaft, there will be shaft.
Shaft.
Ah.
Turbine means shaft should be there. Without shaft there cannot be any rotating motion.
The shaft will be there, and that shaft will rotate that fan.
Fan, yeah. Shaft is connected
Working.
to the fan. Is units are going on?
Yes.
So this is like axial and radial turbine, nothing more about it. So steam, high temperature steam, low temperature and high pressure steam will produce motion in turbine, and that motion will be fed to generator. Steam's temperature will reduce and its pressure will reduce due to moving the turbine, and that reduced temperature pressure steam will come out of the turbine and goes to condenser, gets itself condensed and come back to the boiler.
And
Automatically it becomes-
from there only they will.
It has
Hmm.
been constructed.
From there only they will take water. That steam, which steam is made in, is made burning of the water.
Steam water which was
Rakshak,
now is
you are coming in
even the
between.
turbine has come back, that will be condensed into water and water will be fed back to the
You are
boiler.
coming in between. On both sides.
Mini cycle they will use that.
Yeah. And this
Now
condensing
it's
is done by the cycle of the condensing water in cooling towers. That's it. So that's how it is done. Now this was a very simple cycle which I explained of the thermal power plant. We will see a video in which this is explained in many cycles. It's actually not just one turbine. First of all, there will be high pressure turbine. Then the steam which comes out will be fed to the low pressure turbine. Then again the steam will comes out of that will be fed to the very low pressure turbine, and then it will come out and go to condenser.
There will be many turbines.
Yeah, many turbines.
By that only
Thermal
they
power plant.
Yeah, because low pressure, high pressure and medium pressure turbines are there. It depends, because when the steam is at high pressure, high temperature, the volume of the steam, the space it covers is lesser because it is high pressure. Okay, when it produces motion into the, so at that time it requires less volume. So turbine which is required for that will be of lesser size. It will give more power but of less size. Now when it is expanded, the steam has converted the motion of the turbine. Steam has passed energy to convert the motion of the turbine. So it is expanded, so it will require now more volume. It is also less temperature and it will require more volume. So that will be a bigger turbine.
In first
Size
time
of the
they
turbine
will
will
be
be
small, small. Provided
So low pressure turbine is smaller,
Ah.
then there will be bigger turbine required because more space is required now by that same steam, same amount of steam. So it will go there and it will move the low pressure turbine.
So there will be more, means many turbines, and from that turbine this
Yeah.
generator will be.
Yeah. So many
But
turbines
there will be
together,
only one generator.
one
we
generator
can do just like this.
and many turbines.
There can be means many generators. This
No,
for
but
each,
why to have many generators?
which it will give more energy.
No,
The generator
the
will
whole
give
movement is the same. The movement is collected together of all the turbines
collected
to
to
fed to one generator. It's all in the axial. So RPM is same. Revolution square root. And just because this requires more space, so they have designed a specific turbine for it, which is more space. So like that, and then that is fed back to the condenser. So this is whole power plant cycle.
What is nucleus power plant? Nucleus, I have.
Nucleus?
Nuclear.
Power plant. In that the fuel used is not coal but uranium and nuclear fission, like that which is used in atom bomb.
If it will blast.
So they have more safety measures that it doesn't blast. It did a few times, like in Chernobyl.
I heard in Russia.
It will be a big disaster. Yeah, that is Chernobyl.
Russia, there.
Yeah. Now this one is a better video.
Thermal power plants help meet almost half of the world's power demand. They use
This is the power demand of the whole world. Thermal power plant is giving more than half of the power requirement, and gas power plant means coal thermal power plant is giving more than half, and gas power plant is giving little more than oil power plants, hydroelectric. These are different.
And this is the
water
liquid.
as the working fluid. Today's thermal power plants are capable to run under great efficiency by conforming to stringent environmental standards. In this video, we will see how a coal-based thermal power plant achieves this
Coal-based
in a
thermal
detailed
power plant.
step-by-step manner. By turning the shaft of this generator,
This is
we
generator.
will be able to generate electricity. The generator derives motion from a steam turbine, the heart of the power plant.
This is a steam turbine.
In order to turn the steam turbine, you have to supply a high pressure and high temperature steam at the inlet of the turbine.
You need to give high pressure, high temperature steam.
As the turbine absorbs energy from the high energy fluid, its pressure and temperature drop toward the outlet.
So high pressure, high temperature, outlet, low pressure, low temperature.
Is low pressure what?
You can
Pressure decreased, temperature decreased. Here you supplied, this was the entry. So this moved the turbine, so high pressure, high temperature steam converted into low pressure, low temperature steam, because the energy was supplied to the turbine.
take a closer look at the uniquely shaped steam turbine rotor blades.
These are rotor blades of the turbine. So steam passes like this, so that will turn the
There will be
turbine.
many blades.
Yeah, there will be many blades. Are you able to see this? How this is turned?
Airfoil shape.
This is airfoil
High-capacity
shape.
power plants often use
These are turning. So steam passes here and it pushes the blade in this direction. So it moves.
different stages of steam turbines,
So there are two generators.
such as high pressure turbines.
This is high pressure turbine.
intermediate
Smaller in
pressure
size.
turbine,
This is medium pressure, intermediate pressure, IP turbine.
and low pressure turbines.
And these are big turbines, low pressure.
So now we have met our objective. We have produced electricity from the generator.
So what happens? Steam is supplied to this high pressure turbine. From there the steam is taken back and supplied to low pressure turbine. Okay, and then it is taken out in the condenser.
If
See,
we can
flow
bring
of
the
steam.
low pressure and low temperature steam back to their original
So now, as Rakshak said, that if we can take this low pressure, low temperature steam back to the original,
states,
then our cycle is
which were of
finished.
a much higher pressure and temperature, we can repeat the process.
correct? So we can just take it back here and then cycle is
The
finished.
first step is to raise the pressure.
So then you have to, because low pressure, low temperature, so you have to raise the pressure and then the temperature of the steam and get it back.
You can use a compressor for this purpose.
You can use a compressor to increase the pressure of the steam.
Compressing steam is a highly energy intensive process.
But compressing steam is a highly energy intensive process. It is very difficult to compress a steam.
So,
Yes. And such a
पॉइंट था ना कि वो स्टीम जो निकल रही है, द स्टीम विच इज कमिंग आउट, व्हाई वी आर कंडेंसिंग दैट, व्हाई वी आर कन्वर्टिंग दैट टू वाटर, कांट इट बी डायरेक्टली फेड बैक? just increase the pressure and temperature of the steam and feed it back. But to increase the pressure and temperature of the steam, you need to increase the pressure of the steam, you need a compressor, and compressing steam is a big job
Power plant will not be efficient at all.
because it takes a high amount of energy. So
The
power
easy
plant
way
will be
is to
efficient.
convert the steam into liquid and boost the pressure.
So
For
convert
this
it to
purpose,
liquid.
we'll introduce condenser heat exchangers which sit beneath the low pressure turbine.
So here is condenser.
In the condenser, a stream of cold water flows through the tubes.
Cold water is
The
flowing
steam rejects heat
through
to
these
this liquid
tubes.
stream and becomes condensed.
Steam comes, it gives heat to the water and becomes water. Steam becomes water.
Now we can use a pump to increase the pressure of this feed water.
So the water which was
Typically, multi-stage
condensed will
centrifugal
come here
pumping is used for this purpose.
and pumped back.
That way, the pressure will revert to its original state. The next task is to bring the temperature back to its original value. For this purpose,
So
heat
with
is
the
added
pump,
to
the water is fed back high. So the pressure will increase and then you increase the temperature.
exit of the pump with the help of a boiler. High-capacity power
This is
plants
boiler.
generally use a boiler called a water tube boiler.
It's a water tube boiler.
They will not do this thanda, cold water. They will not do. They will not do.
Pulverized coal
They
is
did.
then burned.
Pardon?
They will not do. They will not do cold water.
It's already condenser cooled the water.
Inside the boiler.
So this is boiler, tube boiler.
What is
The
this,
incoming
Roji?
water initially
Coal is
passes
being
through an
sprayed.
economizer session. Here, the water will capture energy from the flue gas.
Actually the technical term for these bhadka is flue gas. Flue gas.
The
What is
water
this coming
flows
here?
through a downcomer
This is, here the coal is sprayed,
and then
flue
through
gases are
water
going
walls,
like this.
where it transforms into steam.
So the
The
water
pure steam
which was there is
separated
transferred
in a
into steam.
drum. Now, the working fluid is back to its original state, high pressure and high temperature. This steam can be fed back into the steam turbine.
So it is given back to the steam turbine. High
The
pressure
cycle
steam
can be
turbine.
repeated over and over again for continuous power production. But a power plant working on this basic Rankine cycle will have a very low efficiency and a low capacity. We can
So this is Rankine cycle. Here the temperature is not very high, temperature of the steam. So it has about 20 to 25% efficiency. That means if you burn coal which is giving you 100 units of energy, then the moment which you get here electricity, that will be 20 or 25 units of energy. That's 25% efficiency.
increase the performance of the power plant considerably with the help of a few simple techniques.
First is, so how to increase the efficiency? First is superheating.
In case of superheating, even after the liquid has been converted into steam, even more heat is added. And
So this is converted into steam here, but still it will be heated more. These are the tubes for the steam.
with that, the steam becomes superheated.
I didn't.
The higher the
Means
temperature of
it is coming here, then where it is going?
Here it is converted to steam, so that was there before. They have added a superheater. Means already
They have here tubes.
these all are tubes going on, but and here the coal is being sprayed, so the whole of this is full of whole of this unit is full of flue gases. Okay, so now water converted to steam, and that steam is also again heated much more.
How? Please how?
It's whole flue gases are there, so they provided more tubes so that more it will be heated.
the steam, the more efficient the cycle. Just remember the Carnot's theorem of maximal thermal efficiency possible. But the steam turbine material will not withstand temperatures of more than 600 degrees Celsius.
So steel turbine material will not withstand temperature more than 600 degrees centigrade. So we do not supply more superheated steam.
So
We supply
superheating
only
is limited
550
to that
degree.
threshold.